So, ang i-discuss ko po sa inyo ay ang load power flow studies. So, ang load flow studies are performed to determine the steady state operation of an electric power system. It calculates the voltage drop on each feeder, the voltage of each bus, and the power flow in all branch and feeder circuits. So, ginagamit po natin yung load flow para malaman natin yung steady state condition ng isang electric power system. Steady state meaning unchanging. Kumbaga, i-calculate natin yung mga unknown parameters like voltage drop sa feeder, so bus voltages, etc. under steady state conditions. Kumbaga, kahit may mabago at madagdag, ganun pa rin yung system. Which is why ginagamit yung load flow study. Load flow study determines if the system voltages remain within specified limits under various contingency conditions and whether equipment such as transformers and conductors are overloaded. So dito din natin malalaman kung yung system voltages ba natin is nag-i-stick dun sa specified limits na nilagay natin. And kung yung transformer o yung conductors natin is overloaded na. Load flow studies are often used to identify the need for additional generation, capacity for inductive bar support, or the placement of capacitors and or reactors to maintain system voltages within specified limits. Losses in each branch and total system power losses are also calculated. So, dito din po natin. So, sa paggamit po ng load flow studies, kinakalculate natin yung pwede din makalculate yung power losses and yung losses sa each branch. So, necessary for planning, economic scheduling, and control of an system as well as planning its future expansion of system. So, dito po, yung load flow, ginagamit natin in case na meron tayong gustong baguhin sa isang existing power system, or may gusto tayong idagdag. So, sa load flow po, meron po tayong dalawang iterative methods or techniques na ginagamit para makalculate natin yung mga unknown voltages or unknown parameters. Yun po ay ang Gauss-Seidel method at ang Newton-Raphson method. So, ang di-discuss ko po sa inyo ay ang Gauss-Seidel method. So, with the Gauss method, we need to rewrite our equation in an implicit form x is equal to h of x. So, una po, kailangan po natin magkaroon ng initial guess. And then, mag-iterate lang po tayo hanggang sa mahanap natin yung fixed point wherein yung iteration natin is hindi na nagkakalayo or halos same na yung value na lumabas. So, ang advantage po ng Gauss-Seidel is each iteration is relatively fast. Computational order is proportional to number of branches plus number of buses in the system. So, yung iteration po natin is relatively fast as long as yung branches natin tsaka yung buses natin is kakaunti. And then, in proportion siya kung ilan yung branches natin tsaka yung buses natin na nasa system. And it is relatively easy to program. Gauss-Seidel Disadvantages tends to converge relatively slowly. So, yun nga po, nagko-converge. Converge meaning maraming iteration, kumbaga mahabang iteration o maraming iteration ang kailangan para mag-converge o magkatulad ng magiging value natin. Although, this can be improved with acceleration. So, para po ma-speed up yung ating pag-iterate, gumagamit po tayo ng acceleration factor. Has tendency to miss solutions, particularly on large systems. Tends to diverge in cases with negative branch reactances. So, pag meron po tayong negative branch reactances, imbis na papalapit yung values na nakukuha natin kada iteration, imbis na mapalapit sila, mas nagda-diverge sila. Mas lumalayo yung values nila sa source. And it is need to program using complex numbers. Siyempre, una, kailangan natin kunin yung equation ng Gauss flow. So, we all know naman na SI is equals to V times conjugate of I. And alam din natin na I is equal to YB. So, equate lang po yan hanggang sa lumabas po itong equation na to. Which is V I is equals to 1 YII, Y is the admittance, and times S conjugate divided by V conjugate minus summation of Y, V, wherein K is equals to 1 to N. And hindi po dapat, titigil lang po tayo pag as long as hindi pa nag-i-equal yung K sa I. So, ang example po natin ay Gauss Two Bus Example. A 100 milliwatts 50 amp load is connected to a generator through a line with 0.02 plus J 0.06 per unit and line charging of 5 amp bar on each end, 100 MVA base. Also, there is a 25 amp bar capacitor at S2. The generator voltage is 1 per unit. What is V2? So, ang mahanap na po natin is V2 sa yung bus voltage natin dito. So, ang una po natin gagawin is kailangan natin hanapin yung Y bus since yung Y nga po is the reciprocal of one of the impedance 1 over Z, and ang Z po natin is 0.02 plus J 0.06 per unit. So, meaning 1 over 0.02 plus J 0.06 is equals to 5 minus J 15. So, yung Y bus po natin, kung lalagyan natin siya ng matrix, is this. So, sa Y11 po is 5 minus J 14.95. Sa Y12 at Y21, since pareho lang sila, minus 5 plus J 15. And sa Y22 natin is 5 minus J 14.70. So, gamit ng formulang nakuha natin kanina. And since ang hinahanap ang V2, so meaning yung I natin is equals to 2 and K is equal to 1. So, since titigil lang po tayo, as long as hindi mag-i-equal yung K at I, at yung I natin is 2, meaning, ito lang yung, hanggang dito lang yung ating summation. So, using the formula na nakuha natin kanina, V2 is equals to 1 over 5 minus J 14.7, which is Y22, so, times S2, which is negative 1 plus J 0.5 divided by conjugate of V2 minus YIK, which is 1 to 1, which is negative 5 plus J 15, and VK. So, yung VK is nakuha natin, yung ating flat start o yung initial guess natin, which is usually 1 at an angle of 0. So, sa pag-iterate natin, ito yung iteration na nakuha natin. Kung makikita nyo, sa 3 at 4, magkapareha na yung sagot na lumabas sa kanila. So, ibig sabihin, dito na tayo nahanap na natin yung fixed point wherein yung sunod na iteration is same dun sa previous iteration. So, ibig sabihin, ito yung nakuha natin sa sagot, which is the V2. So, V2 is equals to 0.9629 0.0556 or 0.9638 at an angle of negative 3.3 degrees voltage. Yun po yung ating voltage. Once the voltage are known, all other values can be determined, such as the generator powers and the line flows. So, yun nga po. Kumbaga, una na muna natin kukunin, especially ay yung unknown voltages na hinahanap. And kung may iba man pong hinahanap, just such as generator powers and the capacitor, so yun po.
Okay, good morning. I am Ira Joyce Cores, and today I will report about the Newton-Raphson method of load flow. Pero bago tayo magsimula sa Newton-Raphson method of load flow, yung mismong process ng calculation, alamin muna natin kung ano yung mga advantages and disadvantages niya. Ang advantages ng Newton-Raphson is it is faster than Gauss-Seidel method of load flow. It needs less number of iterations to reach convergence and take less computation time. It is more accurate and not sensitive to the factors such like slack bus selection, regulation transformers, etc. and the number of iterations required in this method is almost independent of system size. And it is powerful for solving nonlinear algebraic equations. Yung sa disadvantages naman niya, more calculations involved in each iteration, and it requires large computation time per iteration and large computer memory. It is difficult solution technique or the programming is difficult. Itong figure 1 is kailangan natin siyang tandaan kasi ito yung parang basis ng Newton-Raphson method. Itong delta P and delta Q, ito yung tinatawag na specified quantities. Yung J11, J12, J21, J22, yun yung JACOBIAN matrix. Yung delta, and delta V, yun yung unknown quantities. Bali, ang equation is yung specified is equals to JACOBIAN multiplied by the unknown. Para makuha yung JACOBIAN matrix, sa next slides is i-discuss kung paano makukuha itong J11, J12, J21, and J22. Pero yung pasulyap nito is ang J11 ay equal sa derivative ng delta P over derivative ng del delta. Ang J12 naman is derivative ng P over derivative ng V. J21 is derivative ng Q over derivative ng delta at ang J22 is derivative ng Q over derivative ng V. Ito yung mga formulas na sinabi ko earlier kung paano i-evaluate yung JACOBIAN matrix. Since kailangan nga siyang i-derive, masyadong mahaba or masyadong matagal kung i-derive mo yung equation na yun. Kaya binigay ko yung mga formulas na pwedeng gamitin directly para makuha yung JACOBIAN matrix. In terms of power or real power, ang derivative ng PI over derivative ng delta J if I is not equals to J is equals to negative BI Yij Bj sine quantities of theta ij plus delta J minus delta I. Take note that I is not equals to J. Itong VI na tinuto is given, Yij, yun yung given din, Bj, given lahat ng quantities na hinahanap. Ibig sabihin, kailangan lang natin isub lahat ng given na yun. Ang next formula is derivative of Pi over derivative ng delta J. Ito naman if I is equals to J. Is equals to negative Qi minus Vi squared Bii. Take note na itong Qi dito, meron siyang formula. Mamaya is i-discuss later kung ano yung formula na yun. Ang derivative naman of Pi over derivative ng Vj. If I is not equals to J is equals to Vi Yij Vj cosine quantity of theta ij plus delta j minus delta I. And last is the derivative of Pi over derivative ng Vj if I is equals to J is equals to Pi over Bi plus Vi Gii. Take note na itong Pi din, kagaya nitong Qi or yung reactive power is meron din siyang formula na hindi siya direct sub. May formula siya na kailangan na kunin mo muna yung Pi bago mo ma-substitute dito sa equation nito. In terms naman of Q, or in terms of reactive power, yung derivative ng Qi over derivative ng delta J, if I is not equals to J, is equals to negative Pi Vj Yij cosine quantity of theta ij plus delta J minus delta I. Take note yung Yij is yung admittance. Yung derivative of Qi over derivative ng or yung derivative ng delta J, if I is equals to J, is equals to Pi minus Bi squared Gii. Kagaya ng sinabi ko nung una, yung Pi is meron pa siyang formula. Hindi mo siya pwedeng i-direct sub dito kasi bago mo makuha itong Pi is meron pang isang formula na gagamitin. Yung derivative ng Qi over derivative ng Vj, if I is not equals to J naman, ay equals to negative Pi Yij Vj sine quantities of theta ij plus delta J minus delta I. And last is derivative of Qi over derivative ng Vj, if I is equals to J, is equals to Qi over Vi minus Vi Bii. Take note na yung Qi, kagaya din ng real power dito, is ano din siya, meron din siyang formula na kailangan mo munang gamitin yun para makuha mo yung Qi. And then, pwede mo na siyang isag pagkatapos. And bago tayo magtungo doon sa mismong steps or yung procedures kung paano gagawin yung Newton-Raphson, kailangan muna natin alamin kung ano yung mga uri ng buses na pwede nating makita sa isang bus system. First is yung slack bus. Yung slack bus is kalimitan siya yung bus number 1. Given sa kanya is yung voltage at angle of 0 degrees per unit. Yung PQ bus is kaya siya tinawag na PQ dahil ang kanyang specified quantities ay real power and reactive power, which is P and Q. At yung pangatlong bus is yung PV bus. PV bus is kaya naman siya tinawag na PV bus is gawa nga nung real power and yung voltage is given or specified sa bus na yun. Example is yung figure na to. So figure na to is meron tayong 5 buses. So 5 buses, yung number 1 is yung slack bus. And 2 and yung 4 is sila yung PQ bus. And yung 3 at yung 5 is yung PV bus. Para mas maintindihan natin yung specified at yung anong quantity sa kada bus number na yon, since yung bus 2 and bus 4, according dun sa figure, sila is PQ bus. Kung mapapansin nyo, ang specified quantities nga sa kanila is P and Q kasi nga PQ bus sila, P and Q. Pero itong subscript, take note lang na kaya siya 2 dahil nagpe-pertain siya sa bus number. Kaya real power at bus 2 and the active power at bus 2, kaya P to Q2. While dun sa bus number 4, kung mapapansin nyo, kaya siya 4 dahil nasa bus number 4 siya. P4 or real power at bus 4 and the active power of bus 4. Since given is P and Q, tas derive no, or mula dun sa binigay ko nung una, yung sabi ko na mahalaga nating tandaan yung specified quantities equals to Jacobian matrix times unknown quantities. Kung ito yung specified, ang unknown sa kanya, ibig sabihin is yung delta 2 at V2 niya. Tapos dito naman sa 4, since P and Q, PQ bus din siya, ang unknown quantities din sa kanya is yung delta 4 and V4. Take note yung delta na tinutukoy dito is yung angle ng voltage. Yung P is real power, Q is reactive power, V is voltage. While doon naman sa 3, bus number 3 and 5, sa bus 3 and 5, di ba, PV bus sila. Ibig sabihin yung power or real power at yung voltage is given or specified. Kaya kung mapapansin nyo, sa bus 3, ang specified quantities is P3 and V3. Sa bus number 5, since PV bus din siya, ang specified quantities is P5 and V5. Pero, kung mapapansin nyo, ang unknown quantities is yung nawawala. Sabihin, ang wala sa kanya is yung Q or yung reactive power, tas yung delta or yung angle ng voltage. Kaya, delta 3 and Q3. Kasi, bus number 3 siya. Well, doon naman sa bus number 5 is delta 5 and Q5 kasi nga, bus number 5 siya. And, mula dun sa mismong equation or yung equation na kinakailangan para malaman mo para makapagsimula ka ng Newton-Raphson is yun nga yung example natin na delta P, delta Q is equals to J11, J12, J21, J22 multiplied by delta V. Mula doon, makukuha natin tong ganitong equation. Since ang tinutukoy nga na delta P is yung mga given quantities or yung specified quantities, kung mapapansin nyo dun sa bus 2 to 5, ang given sa kanya ay lahat sila may given na P or may given na real power or specified sa kanila lahat yung real power. Kaya ang magiging matrix niya is delta P is equals to delta P2, delta P3, delta P4, and delta P5. Kasi lahat, di ba sila ay sila is P, Q, and PV bus, specified sa kanila lahat yung P and plus P. Another specified quantities naman is yung Q. Sa Q, ang magiging specified quantities lang is Q2 and Q4. Bakit? Kasi yung bus number 2 and number 4, sila yung PQ bus. Ibig sabihin, specified sa kanila yung Q. Kaya, ang delta Q, which is the specified quantities, is equals to delta Q2 and delta Q4. For unknown quantities naman, dun nga sa sinabi ko, yung specified quantities is equals to Jacobian matrix times unknown quantities. Yung unknown quantities dun is yung delta and yung voltage. Yung delta, itong del delta is equals to del delta 2, del delta 3, del delta 4, del delta 5. Bakit meron lahat na delta dito? Kasi kung mapapansin nyo, lahat ng buses 2 to 4, ay 2 to 5, is PV and PQ ba sila? Ibig sabihin, lahat sila walang delta or walang specified na delta. Kaya, lahat ng unknown quantities is merong lahat dun sa bus na yun, delta 2, delta 3, delta 4, and delta 5. Another unknown quantities is yung voltage. Kung mapapansin nyo, ang meron lang voltage or magkakaroon lang ng voltage is yung PQ bus. Kasi sa PQ bus, walang voltage na given, unlike sa PV bus na meron. Kaya, ang delta V is equal sa delta V2 and delta V4. Ito yung sabi ko na important formulas na gagamitin nyo dun sa formulas na binanggit ko kanina sa pagkuha ng mga Jacobian matrix. Take note na yung PI is equals to VI summation of YI K VK cosine theta IK plus delta K minus delta I. At K is equals to 1 at n terms. Itong n tinutukoy dito is yung kung ilan yung bus. Example is, halimbawa, 5 yung bus. Ibig sabihin yung n dito is 5 hanggang mag-sum up siya sa 5. Ito namang QI, ang difference lang niya is negative BI summation ng YI K VK sine theta IK plus delta K minus delta I. Take note na yung magkaiba yung sign at cosine function and sine function. At K is equals to 1 at n terms. And FR is equals to negative JR minus 1 delta XR minus 1. XR is equals to XR minus 1 plus delta XR minus 1. Example is, kukunin na natin yung first iteration. Para makuha natin yung first iteration, kailangan natin yung initial, yung yung nilet natin or yung initial natin, initial values, or yung sinet natin na initial values, plus itong correction. Yung correction dito, ito din yung tinatawag na unknown quantities. And if delta, substitute, delta XR minus 1 is equals to negative JR minus 1 raised to negative 1 FR. Ito na yung pinaka-important kasi kailangan dito is malalaman na natin kung paano gagamitin yung Newton-Raphson method sa load flow. First step daw is read system data. Second is formulate the Y bus. Third is assume initial values. Fourth is evaluate for the corrections corresponding to the unknown. And fifth is substitute to get the first iteration. Example. For the bus system shown in figure, find the values of D2, delta 2, and delta 3 at the end of first iteration of Newton-Raphson method of load flow. Dito sa figure is makikita natin meron siyang tatlong buses. First bus is yung slack bus. Bus number 2 naman is yung PQ bus. And bus number 3 is PV bus. Take note sa slack bus, kagaya ng una kong sinabi, kalimitan is given talaga yung voltage sa kanya. And kalimitan is angle 0 degrees per, at ang angle 0 degrees siya. Ang value ng V1 natin is 1.05 at an angle of 0 degrees per unit. Sa P2 naman is PQ bus. Since PQ bus siya, given sa kanya is yung P2, Q2. Kaya nga 2 gawa na sa bus number 2 siya. P2 is equals to negative 4.0 per unit, and Q2 is negative 2.5 per unit. Well, doon naman sa bus number 3 is PV bus. Take note, yung PV bus is given sa kanya yung power and yung voltage. Kaya siya 3 is kasi bus number 3 siya. P3 is equals to 2.0 per unit, and B3 is equals to 1.04 per unit. Kung mapapansin nyo sa baba dito, meron siyang tolerance. Itong Q3 kasi, since PV bus siya, nawawala rin sa kanya yung Q, diba? Pero hindi siya kinukuha or hindi siya hinahanap. Kasi ang hinahanap lang ay V2, Delta 2, and Delta 3. Ito Q3 is parang magiging tolerance siya or sukatan. Kung baga, gano'n na kalapit dun sa true value. Kung dito sa Q3, dapat daw yung Q3 is more than 1.0 per unit but less than 1.5 per unit. Dapat within the limit na lang yun. And bago tumaas daw siya, i-consider daw natin siya as PQ bus. Pero pag daw, ibig sabihin, kailangan natin dun sa pinaka-highest level kung saan nandun, nasa pagitan pa rin siya ng 1.0 at 1.5. And given din yung lahat ng impedances, take note, impedance sila, hindi sila admittance. Edi Z12 is equals to 0.02 plus J 0.04 per unit, Z23 is equals to 0.0125 plus J 0.025 per unit, and C13 is equals to 0.01 plus J 0.03 per unit. First step, read system data. Kailangan natin i-analyze kung ano ba yung hinahanap. Since ang hinahanap dito is yung V2 at the first iteration, Delta 2 at the first iteration, and Delta 3 at the first iteration. Kailangan natin hanapin yung values na lahat ng yun at the first iteration, given yung lahat ng lahat ng values, or using lahat ng values na nakalagay dito sa figure na to. And formulate the Y-bus. Gaya nung tinuturo sa atin, di ba ang Y-bus, since siya is 3, or yung 3 buses, ibig sabihin, ang kanyang is 3x3 matrix. Para makuha, take note na mas madali, para makuha yung Y11, Y22, Y33, or yung diagonal niya, or lahat ng values dun sa diagonal, yung i-reciprocal mo lang yung mga nakakabit sa kanyang impedances. Example, kagaya sa Y11, yung lahat ng nakakabit sa 1, i-reciprocal mo lang, kasi add mo lahat ng yun. Yun na yung ilalagay mo dito. And same din sa Y22 and sa Y33. While doon naman sa non-diagonal, kagaya ng Y12, Y13, negative reciprocal lang natin yung value ng impedance. Example is Z12. Yung Z12, para makuha mo yung Y12, is equals to negative 1 over Z12. Kapag naman Y13 is equals to negative 1 over Z13. Yun, ganun lang. Itong lahat ng values na to is given from the values, or given, or kinuha, calculated, lahat mula dun sa figure na nauna. And assume initial values. Take note that assume only VI and delta I initial for PQ buses and delta I initial for PV buses. Since PQ bus siya, ang nawawala sa kanya is V and delta, which is pasok dun sa sinasabi ko kanina na mahalagang equation or mahalagang relations, yung PQ is equals to JACOBIAN multiplied by delta and V. Yun. Ito rin yun. Since PQ is given or specified, sabihin, mag-a-assume lang tayo ng hinahanap is ito. Initial or VI initial and delta I initial. Para naman sa PV bus, kung mapapansin nyo sa PV bus, ang hinahanap lang sa kanya is, or mag-a-assume lang tayo ng delta I. Bakit delta I lang i-assume natin? Kasi, di ba sa PV bus nawawala rin yung Q. Kaya, i-assume lang natin yung delta I kasi itong delta and V na makukuha natin is magagamit natin siya pag-uwa ng Q. Take note that yung Q is may binigay akong formula, yung may summation. Yun. Kalimitang ina-assume na ang voltage Since ang hinahanap natin, di ba, is V2 at the first iteration, ibig sabihin, ang V2 initial natin is equals to 1 per unit. Kalimitan lagi, kapag voltage ang i-assume natin, lahat ng voltage ay 1 per unit. Ang delta 2 initial is equals to 0 degrees. Pero kapag naman delta ang pinag-uusapan is i-assume natin siya na 0 degrees. And the same, delta 3 initial is equals to 0 degrees. Sabihin, lahat ito yung value na hinahanap natin. So, yung value lang din yun na yung, ito ring value na to, yung nagkaroon tayo ng initial values. Fourth is evaluate for the corrections corresponding to the unknown. Take note, itong V2, delta 2, and delta 3 initial ay ay tinatawag din na correction factors. Yung correction factors na yun is also known as unknown quantities. Kailangan daw natin malaman muna ito para makuha natin yung hinahanap natin na V2 first iteration, delta 2 ay in first iteration, and delta 3 in the first iteration. Ito yung based to dun sa equation na lagi kong sinasabi na important. Dito sa pinaka left side is makikita nyo dito yung mga ito yung mga specified quantities or yung given quantities. Kung mapapansin nyo dun sa figure, ang given naman sa atin is P2, Q2, and P3. Kung mapapansin nyo sa bus number 2, given yung PQ bus, kasi PQ bus nga yung bus number 2, kaya given yung P and Q. Well, sa bus number 3, PV bus siya. Given sa kanya yung P3 and V3. Pero yung V3, hindi natin siya isasama as specified dito kasi kung mapapansin nyo yung first equation natin, yung kauna-unahan na sinabi ko nga importante, ang unknown quantities lang sa kanya is yung delta and V. Ibig sabihin, kahit siya ay given, hindi natin siya pwedeng isama dito sa specified kasi nga, this part is for specified quantities only. Ay hindi naman belong yung voltage sa specified quantities according dun sa relation. Is equals naman sa J initial or yung JACOBIAN matrix initial multiplied by delta 2 and del delta 2 initial, del delta 3 initial, and del delta V2 initial. Since nga yung bus number 2 is PQ bus, ang nawawala sa kanya is yung delta 2 and V2. And yung P3 bus, or yung bus number 3 is PV bus, ang nawawala sa kanya is yung delta 3 and Q3. Pero yung Q3 hindi natin isasama sa specified or sa unknown quantities kasi ang Q is pertaining siya dun sa specified quantities. Para lang natin yun dito, is makikita nyo is nagkakaroon lang ng subscript or para mas malinawan kung paano yung JACOBIAN matrix, kung ano mangyayari sa kanya. Para makuha yung J11, kagaya na sinasabi ko nung una, derivative nito over derivative nito, itong delta 2. J12 naman is derivative ng P2, derivative ng delta 3. J13 is derivative ng P2 over derivative ng V2. And the rest is the same. Ganun din. To calculate the corrections, to calculate nga yung corrections na delta 2 initial, delta 3 initial, and V2 initial, kailangan muna natin hanapin yung delta P2 initial, delta P3 initial, and delta Q2 initial, tas yung JACOBIAN matrix. Take note na yung delta P2 initial is equals to P2 specified minus P2 calculated, or P2 initial specified minus P2 calculated. If P2 is specified is equals to negative 4.0 per unit, specified na to or yung given. Ang P2 calculated is equals to V2, summation ng Y2K VK cosine theta 2K plus delta K minus delta 2. Take note na itong formula na to is na-discuss ko earlier. Makukuha na natin yung P2 calculated na kapag sinubstitute mo lahat ng unknown quantities or yung V2 or yung Y21, V1, lahat, nakukuha natin yung P2 initial calculated na negative 1.14 per unit. Kaya, ang makukuha na natin yung delta P2 initial, which is yung nang specified na negative 4.0 minus calculated na negative 1.14 is equal sa delta P2 is equals to negative 2.86 per unit. Para naman dun sa delta P3 initial, gaya ng same formula dun sa P2 na ginawa, P3 initial specified minus P3 initial calculated. P3 initial specified is equals 2.0 per unit, given yan. And P3 initial calculated is yung ng formula na VI summation ng YIK, VK cosine theta IK plus delta K minus delta I. Take note na yung delta I, ano siya, yung I equals siya sa 3 kasi nasa bus number 3. And yung N sa taas equals siya sa 3 kasi ang number of buses natin is 3. Pag sinubstitute mo lahat ng values, makukuha mo na yung P3 calculated na 0.5616. After that, proceed ka para makuha na yung delta P3 initial na P3 specified minus P3 calculated na 2.0 per unit minus 0.5616 per unit is equals to 1.4384 per unit. Sa Q2 is ganun din ang mangyayari. Delta Q2 initial is equals to Q2 initial specified minus Q2 initial calculated. Given ang Q2 initial specified na negative 2.5 per unit. If Q2 initial calculated nga is yung gamit yung formula na binanggit ko earlier and substituting all those values, makuha mo yung Q2 initial calculated na negative 2.28 per unit. Kaya makukuha mo na yung delta Q2 initial na Q2 specified minus Q2 calculated is equals to negative 2.5 per unit minus negative 2.28 per unit. Magiging sagot dyan is delta Q2 initial is equals to negative 0.22 per unit. For the Jacobian matrix naman, yan. Diba sinabi ko kanina, yung J11 dito equal siya sa derivative nitong P2 over derivative ng delta 2. Yung J12 is derivative ng P2 over derivative ng delta 3. Tapos ito namang J13 is derivative ng P2 over derivative ng B2. Ito namang J21 is derivative ng P3 over derivative ng delta 2. And the rest is ganun. Ngayon, itong mga nabanggit ko, itong lahat nitong nasa loob ng Jacobian matrix, kailangan muna natin kunin yan. Nakuha na natin to kanina, ngayon. Ngayon, ang kukunin naman natin is ito, lahat ng values dito, para makuha natin itong corrections or correction factors. Paano makukuha to? Gamit yung mga formulas na binanggit ko rin kanina or na-discuss nung una. Yan. For dun sa unang, for the J11, ito yung equation, and ito yung formula, binanggit ko kanina. Pag makukuha natin yan na, ibig sabihin ng J11 natin is equals to 54.28 per unit. Yung J12 naman natin, if derivative ng P2 over derivative ng delta 3 initial, if I is not equals to J, given yung formula na binanggit ko or na i-discuss kanina, is equals to, makukuha natin yung sagot na negative 33.28 per unit. Yun namang J13 naman is yung derivative ng P2 over derivative ng V2 initial. If I is equals to J is equals to yung formula. Ngayon nga, sabi ko yung P2, may formula pa yun. Itong lahat ng to simula dito hanggang dito. Summation yan. Over V2 plus V2 G22. And then sub mo lang lahat ng ng values, makukuha mo na yung yung J13 na 24.86 per unit. Next is yung J21, yung derivative ng P3 over derivative ng delta 2 initial, phi is not equals to J. And may equation tayo or may formula. Then substitute ng lahat ng values, makukuha natin yung J21 na negative 33.28 per unit. Yun namang derivative ng P3 over derivative ng delta 3 initial, if I is equals to J, Given yung formula, then again, substitute yung lahat ng values. Then, makukuha natin yung J2 na 66.04 per unit. Yun namang derivative ng P3 over derivative ng V2 initial if I is not equals to J is equals to V3, yun nga, Y32 cosine theta 32 plus delta 2 minus delta 3. Substitute ng lahat ulit ng values, makukuha na natin yung yung J23, which is negative 16.64 per unit. Yung derivative naman ng Q2 over derivative ng delta 2 initial if I is equals to J, ito yung kanyang equations or yung formula. Then, isab lang natin lahat ng nawawala. Makukuha na natin yung J31 na negative 27.1401 per unit. Then, the derivative ng Q2 over derivative ng delta 3 initial if I is not equals to J is equals to negative B2, B3, Y23, cosine quantity of theta 23 plus delta 3 minus delta 2. Makukuha na natin, isab lang natin lahat ng values again na nawawala. Makukuha natin yung J32 na 16.64 per unit. And yung derivative ng Q2 over derivative ng V2 initial if I is equals to J, again, given yung formula or yung equations, isab lang natin yung mga unknown or yung mga given quantities. Makukuha na natin yung J33 na 49.72 per unit. Since meron na tayong values from J11 hanggang J33, ito, meron na tayong J11 hanggang J33 initial. Meron na tayo na P2, P3, Q2. Sabihin, makuha na natin tong correction factors, which is del delta 2 initial, del delta 2 initial, and delta V2 initial. Pero, kung mapapansin nyo, di ba, itinranspose na kasi ito. Itong P2, di ba, ito talagang J, nakamultiply siya dito sa unknown quantities. Para nga malaman yung itong unknown quantities, kailangan niyang i-transpose or ilipat. Sabihin, itong Jacobian matrix is magiging raised to negative 1 multiplied by delta P2, delta P3, and delta Q2 or initial. Paano natin malalaman yung initial or Jacobian matrix at initial raised to negative 1? Take note na initial or Jacobian matrix initial raised to negative 1 is equals to adjutant ng Jacobian matrix initial over determinant ng Jacobian matrix. Unahin muna natin is yung determinant. So, determinant is, alam nyo na naman siguro kung paano kumuha ng determinant. Pwede sa kalatiw or pwede rin mano-mano. Kopyahin mo lang itong dalawang row, sunod-sunod dito. Tapos yung lahat ng pakanan is plus. Lahat ng pataas na pakaliwa. Tama. Lahat ng pataas minus. Lahat ng pababa plus. Ang kuha natin yung determinant ng Jacobian matrix na equals sa 153,951.4263. Yung adjutant naman, kung mapapansin mo yung adjutant is, pag tinanggal ko to, itong nasa unang part is, tanggal itong dalawa. Sabihin, 66.04 times 49.72 minus 16.64 times negative 16.64 equals siya sa 3560.3984. Pagdating dito sa pangalawa, tanggal naman to. Sabihin ng matitira is negative 33.28 times 49.72 minus negative 27.1401 times negative 16.64. Ang sagot niyan is 2,068.352. Pero ba't nandito? Kung napapansin nyo, kapag adjutant kasi, yung sagot niya dun sa mismo kinukuha natin is yung niya is, yung columns and rows niya is magbabaliktad. Kaya yung nandito, dapat is mapupunta dito. Well, tapos yung nandito is nandito. Yan. Makukuha na natin yan. Ibig sabihin, makukuha natin yung Jacobian matrix initial raised to negative 1 as itong 3560, i-divide mo lang ng 153,951.4263. Ito na yung magiging sagot. And the rest, ganun din yung way. Ngayon, meron na tayong matrix para sa initial Jacobian matrix raised to negative 1. Makukuha na natin yung itong factor or yung correction factors. Itong initial Jacobian matrix raised to negative 1, nakakakuha lang natin, multiply lang natin dun sa una nating nakuha, yung delta P2 initial, Q2 initial, and P3 initial. Paano siya makukuha? Para makuha yung delta P2, delta 2 initial, equals lang siya sa 0.0231 times negative 2.86 plus 0.0134 plus 1.4384 plus negative 7.067 times 10 raised to negative 3 multiplied by negative 0.22 equals siya sa negative 0.04452. Yung delta 3 naman is initial is equals to delta 3 initial is equals to 0.0137 multiplied by negative 2.86 plus 0.0219 multiplied by 1.4384 and plus 4.9287 times 10 raised to negative 4 multiplied by negative 0.22. Ito namang i-equal sa negative 0.77895 times 10 raised to negative 3. Ito namang delta V2 initial is equals to negative 0.0266. Makukuha siya gamit itong 8.0451 times 10 raised to negative 3 multiplied by negative 2.86 plus 2.1617 negative 3 times 1.4384 plus 0.0161 times negative 22. Makukuha yung V2 initial na negative 0.0266. And again, makukuha na natin yung first iteration. Since ang first iteration nga para makuha natin is yung initial natin or yung guess values plus yung corrections. Sabihin, kung delta 2 and delta 3 natin is 0, ang delta initial or delta 2 at the first iteration is equals to 0 degrees plus negative 0.0452. Take note, yung ito is naka-radian, kaya kailangan natin i-degree. And kagaya din yan, naka-radian, kaya ang i-degree. Ito, naka-per unit na to, kaya no need. 0.0266. Kaya ang magiging sagot is initial or delta 2 initial, or delta 2 at first iteration is negative 2.5898 degrees. And delta 3 at the first iteration is equals to negative 0.4463 degrees. And V2 at the first iteration is equals to 0.9734 per unit. Para malaman natin kung ba siya. Since ang QI is equals to VI, summation ng YIK, VK, sin theta IK plus delta K minus delta I. If I is equals to 3, then sub lang. Since 3 nga yung bus number natin or yung lahat ng bases natin is 3. Yan. Isub mo lang yung lahat ng nakuha mo. Itong nakuha natin na bagong factors or yung correction factors. Makukuha na natin yung Q3 at first iteration na 1.4073 per unit, which is within the range. Thank you.